Hello, my name is Francis Uedra, and this is my Physics 2212 Lab 4 Circuits. The goals for this lab are to predict circuit behavior with series and parallel resistors, measure current and potential using a multimeter or an ammeter, and exploring resistor and capacitor behavior. Some of the results were that the node and loop rule were proven to be true from the observations and experiments. Some of the important physics concepts that were used in this lab were the node rule, which essentially is that currents entering the node and currents leaving the node are equal to each other, as well as the loop rule, which is essentially that the sum of all the voltage drops around the loop equals zero. Additionally, one of the most important physics concepts that we used for this lab was Ohm's law, which can be summarized as voltage is equal to current times resistance. For the first portion of the lab, the experimental observations included a circuit, and that was a system, while the surroundings was everything else. The circuits are made up with two 1.5-volt batteries, two resistors, and then some wires, as well as some ammeters that were connected to the circuit. The first question was predicting the current values that will be measured by the ammeters. So from the math, you can see that the 1.5-volt batteries together make up 3 volts. And then from the resistance, we had a 47 ohm resistor and a 100 ohm resistor, which add up to 147 ohm resistance total. We used Ohm's law, which is V equals I times R, and then rearrange it to find current. And our predicted value from our calculations was 0.02, while the observed current that was seen using the ammeter during the experiment was the same value of 0.02 amps. What happens if you reverse the connections of one of the ammeters? If you do this, then the ammeter will read the same value for current, but the sign will be the opposite sign. If one of the ammeters is replaced with a voltmeter, the ammeter reads 0 amps because the voltmeter has a very high resistance, while the voltmeter is going to read 3 volts because there's no other voltage drop at that point in the circuit. And here you can see on the right a little graph of the voltage drops around the circuits, and at the end you can see that the sum of all the voltage drops is 0 volts, which makes the loop rule to be proven to be true. Attaching the voltmeter doesn't change the ammeter reading because very little current flows to the voltmeter in the first place because it has a very high resistance. And if the current through the other ammeter is affected if the voltage is replaced with one of the ammeters in parallel with the 100 ohm resistor. This is because the ammeter has a very low resistance, so the current will flow through it rather than the 100 ohm resistor, which will effectively lower the total resistance of the circuit to 47 ohms. This is because current tends to flow to the path of least resistance. And then from this, the observed current was 0.07 amps. Here you can see some of the math for the resistance values of each circuit component. And if you notice, the resistance of the wire and the ammeter were considered zero, while the resistance for the 47 amp was 48.5 ohms and the 100 ohm resistor was 104 ohms calculated. For the RC circuit, we were able to build the actual RC circuit, but that was where we were able to stop because we had a lack of materials in the lab for the different timings and calculations for the different ohms of the or amps of the light bulb. So we weren't able to complete this part of the experiment, unfortunately, but we were able to build the circuit. Some sources of error are inaccurate measurement from the ammeter, voltmeter, some errors in circuit building, or maybe some calculation errors. Thank you.